Good morning, afternoon, or whatever it is. Um, so we're gonna keep going with this. I've been doing Advent of Code for the last few days, trying to catch up. It's the 15th of December, so you can see day 15 has already been published apparently, so day 16 coming out in 15 hours. And I've been trying to catch up. I've been doing quite a lot over the last few days. I'm on I finished day 8 last night. I think I did days maybe 4 and 5 on stream. 3 and 4, something like that. I think it was 3 and 4 that I did on stream. Can't remember. But I've been keeping up with it. I want to keep going because I'm enjoying it, and I'm also bored. So that's it. So I haven't had a look at day 9 yet. That's the plan for today, though, is to have a look at, well, hopefully do more than one. We'll see. Last time I streamed, I was hoping to do 2, and then I barely even finished 1. So we'll see. We'll see how far we get. I have quite a bit more time today than I did the other day, so hopefully we can get a bit further. But I might get bored of doing coding, and then I'll just stop. So we'll see. And just as a bit of context, then, I'm doing it all in Python because I've never really done any coding in Python before, not properly. So I thought it'd be a good opportunity to kind of learn a little bit of Python. Because anytime I have to actually write code in Python, I end up having to look up how to write every single line of code because I never remember how anything works. So I'm hoping that through this process of trying to do Advent of Code in Python, I will hopefully learn Python and not have to look up every single thing every single time I want to use it. So that's the idea. And I think it's been working. So when I was doing days 1, 2, and 3, I was needing to Google every single thing, and by now I'm only having to Google things every now and then. So that's nice. We're looking at the code for day 8, part 2, here on the left. I suppose one interesting thing to mention about this is that for part 2 especially, in part 1 you can very easily just essentially brute force it. It's not really brute forcing, it's just doing what it's kind of telling you to do, which is to kind of follow a path. I can't remember what the term for this is, but this is an area of mathematics where you have nodes with paths connecting to them, and I can't remember exactly what this area is called or what all of these things are called, but I think it's a regular language, regular grammar. I can't remember what it is. But the point is we have nodes and characters, in this case, connecting to, or I suppose directions, so either left or right. That's our alphabet. There we go. So that's our alphabet. We only have 2, let's say, characters or letters in our alphabet. Go left or right. And we have nodes, and they connect to other nodes depending on if we go left and right, and so on. But for part 3, we are looking for the way it phrases it really kind of hints you at doing it a particular way, which is the most kind of intuitive way of doing it, because what you need to do is we actually have multiple paths or multiple multiple paths we're trying to follow simultaneously, and we want to see when they all end, but we need them to all end at the same time. So if one ends, we keep going until it ends again, if that makes sense, because it's periodic, so it keeps repeating. So we can see that in this example where we start at 11A and 22A, and we're finished when both of them are on a Z. So we go left first, and that takes us to 11B and 22B. Neither of them are finished. We go to the right, and we get to 11Z and 22C. 11Z is finished, so this one is finished, but because the other one isn't, we have to keep going. So we keep going, and the next step, actually the second one is finished, but the first one isn't. So we keep going until eventually we reach a point in which they're both finished. And especially the way it's described, it it's very clearly kind of nudging you towards basically doing that. You have, in the case of the actual input, you have, I think, 6 different paths to follow simultaneously. And you need to keep following them up until they all are finished in the same step. But it turns out it takes a long time to get there. And so you actually need to come up with with a different way of doing it. And the way of doing it is realizing that the number you're looking for is actually the least common multiple of the steps it takes for each one of the individual paths to be finished. So in this first example, you can see the first path, let's say, the one that starts with 11A, you can see it finishes every 2 steps. It takes 2 steps to finish, and then it finishes every 2 steps. Whereas the one on the right finishes every 3 steps. And so the step at which they're both going to be finished is the least common multiple of 2 and 3, which happens to be 6. So even though it tells you a good few times that what you need to do is to do all paths simultaneously, what you actually want to do is figure out how many steps it takes to do each one of those paths individually, and then find the least common multiple. Now, I did it the lazy way, which was apparently the math Python library has a least common multiple function, which is very, very nice and useful. So I could just use that. I did consider trying to figure it out myself, but it turns out it's not as, it's not a very straightforward algorithm. And I wasn't really bothered at like 2 a.m. last night to try and figure it out exactly. But it seems like the most efficient way to do it algorithmically, if you're trying to find the least common multiple of a series of numbers, is to find the greatest common divisor. And then there's some kind of formula where you can get to the least common multiple by having the greatest common divisor. But finding the greatest common divisor is also a whole thing. And there's I think it's some like Euler had some kind of algorithm or something where he described how to get the greatest common divisor. And so you're implementing this whole algorithm that's quite annoying to make just to get the greatest common divisor, and then you have to use that to get the least common. And so I decided, you know what, I'm not bothered to do that. I'm just going to use the math.lcm method, and that'll do. And it worked, which is great. And it gave me the answer in like 200 milliseconds, which is great. You can see how big the answer was. This is why, it would have taken so long. Well, it was taking quite long to actually get the answer by, I suppose it's not really brute forcing it, it's doing it, by following the instructions. But in this case, following the instructions wasn't enough. You had to kind of realize that there is a slight kind of shortcut that you can take, that you don't need to go all the way until they're all finished. We can calculate how long it'll take. So yeah, you can see that's quite a big number, hence why it took quite a while to reach the answer if you did it normally. I'm not sure, I never actually did let it run, so all I saw was, okay, it's been like 30 seconds and I don't have an answer, so this clearly isn't working, let's figure out something else. But it might have only taken 40 seconds and maybe I just missed it. I don't know. I haven't kind of gone through it, and maybe if you weren't doing it in Python, you were doing, I don't know, C or something that's a little bit more optimized, then it might actually run relatively quickly. I don't know. But I thought it was an interesting exercise because it clearly leads you towards a path that actually, well, it's a bit of a red herring. Anyway, that's day 8. We're not here to talk about day 8. We're here to talk about day 9. So let's have a read through day 9. As I said, I haven't actually read this. So let's make this bigger, and we'll read through it together. Spoilers, obviously. I mean, I've already spoiled day 8, but if you're actually, hoping to work through this yourself, then don't watch. Just do it yourself, because I'm going to be spoiling not just the, the storyline, but the puzzles themselves, and hopefully I'll be solving them and giving you the answers. So, I encourage you to actually not watch this stream and go and do these for yourself. But if you don't want to do that, then fair enough. I'm going to go through it now. So, day 9, Mirage Maintenance. Don't like this word. don't know if I'm pronouncing it right. You ride the camel through the sandstorm. That's right, we are riding a camel through a sandstorm on Sand Island, in case that wasn't clear. And stop where the ghost's map told you to stop. The sandstorm subsequently subsides. Difficult to say. Somehow seeing you standing at an oasis. That's very nice alliteration, can I just say. I don't care about the coding anymore. Sandstorm subsequently subsides, somehow seeing you standing at an oasis. That's very nice. The camel goes to get some water and you stretch your neck. As you look up, you discover what must be yet another giant floating island. This one made of metal. I guess that's our next destination. That must be where the parts to fix the sand machines come from. There's even a hang glider partially buried in the sand here. Once the sun rises and heats up the sand, you might be able to use the glider and the hot air to get all the way up to the metal island. I like that there's in a lot of the kind of storylines, certain words have links to like Wikipedia articles explaining what they are, and I'm not really sure why or why those specific words are chosen. As if someone hang glider maybe, but there was a few maybe in day 8, was it? That just didn't make a whole lot of sense to me. I know it must have been day 8. Camel, yeah, there we go. Oh. Why do we need the Wikipedia article to a camel? I think everyone knows what a camel is, no? Anyway. So, we need to unearth the hang glider, do we? Or unsand? Or wait for the sun to rise? Okay, so while you wait for the sun to rise, you admire the oasis hidden here in the middle of the desert island. Must have a delicate ecosystem. You might as well take some ecological readings while you wait. Of course. Maybe you can report any environmental instabilities you find to someone so the oasis can be around for the next sandstorm-worn traveler. You pull out your handy oasis and stand instability sensor. Which... I like that. And analyze your surroundings. The oasis produces a report of many values and how they are changing over time. And that's our puzzle input. Each line in the report contains the history of a single value. For example, the first line is a single value and its history is 0, 3, 6, 9, 12, 15, and so on. 1, 3, 6, 10, 15, 21, 10, 13, 16, 21, 30, 25. To best protect the oasis, your environmental report should include a prediction of the next value in each history. To do this, start by making a new sequence from the difference at each step of your history. If that sequence is not all zeros, repeat this process, using the sequence you just generated as the input sequence. Once all of the values in your latest sequence are zeros, you can extrapolate what the next value of the original history should be. In the above dataset, the first history is 0, 3, 6, 9, 12, 15. Because the values increase by 3 each step, the first sequence of differences that you generate will be 3, 3, 3, 3, 3. Note that this sequence has one fewer value than the input sequence, because at each step it considers 2 numbers from the input. Since these values aren't all 0, repeat the process. Values differ by 0 at each step, so the next sequence is 0, 0, 0, 0. This means you have enough information to extrapolate the history. Visually, those sequences can be arranged like this. Okay, so this is kind of, yeah, it's just kind of figuring out the pattern by finding the differences. Okay. To extrapolate, start by adding a new 0 to the end of your list of zeros, because the zeros represent differences between the 2 values above them. Yeah, this also means there is now a placeholder in every sequence above it. Right? You can then start filling in placeholders from the bottom up. A needs to be the result of increasing 3 by 0, value below it. This means A must be 3. And now B must be 15 plus 3, which is 18. There we go. Finding all 0 differences for the second history requires an additional sequence. Right, so we go 2, 3, 4, 5, 6, 1, 1, 1, 1, 1, 0, 0, 0. I mean, going to the 0, 0, 0 is... I suppose the benefit of that, because obviously we can stop when we realize that they're all the same. We don't need to go to the zeros. But I suppose figuring out that they're all the same involves kind of figuring out, sort of kind of going through the whole thing and seeing if, yeah, I don't know. I think we could probably just stop one step before. But anyway. Then, following the same process as before, work out the next value in each sequence from the bottom up. The next value of the second history is 28. Third history requires even more sequences, but its next value can be found the same way. The next value of the third history is 68. If you find the next value for each history in this example and add them all together, you get 114. That should be 18 plus 28 plus 68. I'm just going to take their word for it. That's 114. Analyze your OASIS report and extrapolate the next value for each history. What is the sum of these extrapolated values? Okay. So, I sense some recursion, is what I'm sensing. So, I need to wrap my head around this now. Anyway, let's go back to the coding then. I'm gonna make a new folder, obviously, for day 9. Right. This day 9. I know you can't see that at the bottom. And I'm gonna do A is gonna be the name of this file. B, which hopefully be able to solve later on. Alright, let's just clear all this code anyway. For day 9. Don't have an input yet, and I think we'll use this as our starting well, this will be our test data. We have a lot of tabs open that we no longer need. That, and currently empty, that's fine. Okay. So yeah, I sense some recursion. Because what we want to do is for every single line, let's look at an individual line. So if we have 0, 3, 6, 9, blah, 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 we want to go through the line and, well, just store the differences between each one. Once we have that, we want to repeat the same process for this new sequence, and so on, until we reach zeros. So that's easy to do recursively. Now my question is, how do we then go back up and figure out that? That's what I'm kind of trying to wrap my head around now, which is once we reach the zeros, then what? Now, I maintain I'm not actually going to get to the zero. I mean, that's going to be marginally faster. It's not going to be a huge improvement. But I insist that getting to the zeros is an extra step that is not actually needed. Once we get to the end, if I haven't seen any numbers that are different, well, then we can just... the next number is a 3. But is it maybe... Yeah, no. I think it will be beneficial maybe to okay, let's write this recursive function. So let's so we want to find differences. Yes, yeah, fine. Let's call it find difference, or let's just call it differences. Difference. What it calls it. Let's out. Yeah, let's call it differences. Let's call it, and this is gonna take in a list of digits. So this is gonna take in a sequence, which we're gonna call sec, something like that. So what do I want to do? Well, first of all, since this is gonna be a recursive function, if what do I want to... See, that's the question now. What do I want to return? Well, I want to return... yeah, I'm not too sure now, actually. What do I want to return? This is the question. Okay, let's start out by just figuring out what we're our kind of base condition, our exit condition, I should say, is going to be that the sequence we've been given is all zeros. So we could do that by adding them adding up the entire list, and if that's 0, well then that's that. So if I think we can do sum, right, of the sequence is equal to 0. Let's start out by just printing out, I don't know, done. Let's just start by doing that. And maybe we'll just return. Otherwise, this is where it gets recursive, because what we want to do is we want to go through the list. We want to create a new list. So, let's call it. It's gonna be a new list. And what I want to do is I want to have a look at a pair of digits. And find the difference between them. So that's easy enough. So I'm gonna go for I. I'm gonna do a range for it. So for I in range, sequence, length of sequence, I should say. Except that I want to go all the way to the end because I'm gonna get because my list is gonna be one shorter. So it's actually gonna be the length of sequence minus 1. I think that makes sense. And so what I want to do in here is call it diffs. That's a better name for it. One diff, the diff is going to be equal to sequence at I plus 1 minus sequence at I. And so this is why that minus 1 here is important, because I'm going to be looking forward a little bit. I could easily, I could also just as well do start at 1 and go all the way to the length. And then actually, I think I will do it this way, so I'll do it like this. I think this works as well. And I'm not going to bother saving this into a variable, I'm just going to append this to my diffs list. And then we just return this, don't we? So, okay, let's just test this out. Well, let's, how do I want to do this? So this isn't recursive yet, you might have noticed. So let's, I just want to see what happens when we print out, let's say, let's start off by just actually putting in 0, 0, 0, 0, for example. We get done and then none. Why do we get none? Couldn't get none, because the sum is 0. Okay, sorry, we just returned nothing. What happens if I do it like this? I'm not sure, because obviously in something like C or Java, which is what I'm usually used to writing in, I need to have a return type for my function. But in this case, Python doesn't need a return type. But does that mean you can have different return types on function? So here I'm not returning anything, and then, so will this give me some kind of error? No, okay, it just adds a return on its own. Okay, that's fine. Okay, that's fine. So it found that it's 0. Let's now try putting in 3, 3, 3, 3. So you can see it returns 0, 0, 0. So the difference between, okay, so that's good. And let's go one step further. We can go 0, 3, 6, 9, 12. And that gives us 3, 3, 3, and so on. Okay. So that's good. I'm thinking, and I actually, yeah, I'm not sure. So, if the sum... Hey, Josh. You've joined me on day 9 of Advent of Code now. And we're about to do some recursion, I think. So, let me think this through again. So what I want to do here, I always find it quite hard to wrap my head around these recursive problems. So Yeah, to be honest, I think I've gotten a lot more comfortable with Python as the days have gone on. Days 1, 2, and 3, I was literally having to look up things like how to write a for loop. Like it took me quite, and like looking back at this now, there's things I would do differently even now that I've learned. So this is the the Pythonic way of doing things. But I think I've gotten to a point where I don't need to look up every single thing I'm doing. I can do most things on my own, and I might just need to look up, how do you write dictionaries again in Python? I can't remember how do those work and so on. But I think mostly I've gotten used to it. Okay, let's just return an empty list, if that's what happens. And I mean, I don't like the way this is written, but anyway, that's fine. This should work. So if now we do, I don't want to return divs. I actually want to return this, right? So I believe what will now happen is, even though I put in something that has quite a few differences, I'm actually always going to get an empty list back. There we go. Just to kind of prove to you that that's working, I would like to print out the diffs. No, not here. Oh no, there. There we go. So you can see I input 0, 3, 6, 9, 12. So it found the differences between those were 3, then the difference between those are 0, and then it returns an empty list. Now, what I want to do then, however, when I recursion can be quite kind of tricky to wrap your head around at the start, but it kind of jumps out at you then afterwards. It's like you see a problem and you're like, okay, well, this is clearly going to be recursive, and it's annoying. So this is an example of this, where it's like, okay, well, I know this is going to have to be recursion. You could do it without it, but it's like, it's a problem that's begging for a recursive solution. And so it's just about figuring it out. So now what I'm trying to figure out, this is kind of the trickier part. I've figured out all my differences, but now what I need to do is I need to go back up. And when I go back up, I need to extrapolate, I think is the word that I used here. Oh, maybe they didn't use extrapolate. No, they just used filling up. Anyway, I'm going to use extrapolate as well. Oh, no, they did. There you go. Information to extrapolate the history. I wasn't wrong. So now the problem is, when I reach 0, what I actually want to do is I want to go back up to the previous level. So I don't want to return difference of diffs. Well, okay, so let's get... So let's say next diffs, I suppose, is going to be equal to this. And then what I actually want to return isn't the difference. It's not this. It's actually this. So I want to append to this. So diffs dot append. What am I appending? So I'm appending. So, okay, let me explain what I'm doing. So, when we put in 0, 3, 6, 9, 12, I'm just going to type it in here. 0, 3, 6, 9. Maybe I'll just copy this here. Easier. So, we pass in 0, 3, 6, 9, 12, 15. When we reach 0, that's just going to return... Okay, well, we'll think about what needs to be returned there. So then what do we actually want to do is when we go back up, I don't want to return this difference. What I want to do is return this difference plus a new number, which is going to be equal to this plus this. So we're going down one more step here. So what I actually need to do here is I need to return the list with the item 0 in it, so that then I can go up here and add a 0 to it. Like so. And then I can go up here and say that this is 3. And then I can go up here and say that this is 18. So the way I do that is we append the sum of the last item in this, so this, plus the last item in next. I think. And then we just return this. So, okay, so what have we done wrong here? So, it's printed out 33333, it's printed out 000. Then it got to 0. I suppose I want to print it out, so I want to print this out, then, and then this. Yeah, okay, so that worked. But then it's not going back up to do the last one. And that's because this shouldn't start as an... Is it sequence that I want to do? Yeah, it's sequence. Okay, it's not sequence. Ah, okay, I'm getting confused here. So... Okay, let's go back here for a second. Where is it printing out 3333? Well, it's printing it out here because it's figured out that the... Let's print out sequence. So, it's receiving 036912. It's figuring out the differences. That's 33333. Then it's getting the next difference. So it's received 33333. Difference between that is 000. Then it calls that. Let's add a print here. Print 0. That's right. So it prints out 000. We reach 0. So we return 1, and so you can see that we've now gone back to here, and we've added that 0 to that, which means we jump back up a level again, and we'd add a 3. But the problem is we end up returning this. Hello, welcome. You join me in a cloud of confusion when it comes to recursion here. We're getting there. I think we're getting there. So we have this now. We've added a 3, which is great. Last thing we need to do is go up one more step. So that the reason this isn't working is that we start off as an empty list, right? So, well, I suppose that's fine. So I suppose that's fine. So the difference. Okay, no. I think this is fine. I think this is actually working. I just wasn't doing the right thing with it. But I think this is working. So it's printing out 33333. Great. Okay. So then all we need to do is let's make a sequence here. So this is our initial sequence. The differences is going to be equal to, well, differences of this sequence. And all I want to do is, just like we did earlier, well, it's this, isn't it? So I want to append to my sequence sum of the last one, the sum of the last item in my sequence and the last item in my differences list. This is my answer. And I want to print out my sequence. There we go, 15. So that worked. That worked. So let's try it out again there. Okay, well, that did work. So all I want to do now is read my file, and we're going to start by reading so data. We're going to open up our test file, which is just these lines here, so our example. This will be in quotation marks. So we open that up, and what I want is I wrote a nice little function in one of my earlier days here. It's day 6 where I have like a read numbers function that just returns all of the numbers in a nice little list. So let's do that. I'm gonna copy that function and reuse it because it's useful. But I'll walk you guys through it. So we're reading a line. This actually, no, this does it a different way to what I want. This is day 6. Oh no, this is right. Okay, that's fine. Okay, no, sorry. This is right. So what we're doing is we're going through each character in a list. If we find that the character is a digit, we save that into a variable. And once we find something that isn't a digit, we put that variable then into we save that number into a list. Now the interesting thing happens when we have a number that's not a single digit. So for example, we find this 12. Well, we find a digit, so we save that into a variable 1. But we now find another digit, so what we do is we multiply the variable by 10 and we add 2. So this becomes 10 plus 2, which is 12. And then again we find a space, and so we save that number, which is now 12, into the list. So this is what this code is doing. So it's going to get the line of code, or the line of numbers, and it's going to create a list of them. So that's it. So let's do that. So for every line, so for a line in my data, I want to, my sequence is going to be read numbers. I can actually just copy that. There we go, read numbers line. And then I want to do this. Like so. And so then actually what I want to do, it's not necessarily, I don't really need to append it to the list because all I care about is my last number. It's the new number that we've created. So next, let's just call it next. Next numbers, is the next number in sequence is going to be this. So the last number in my sequence plus the last number in my difference list. And with that, I think I can make this function better. I'll come back to that, but I think I can make it better, more space efficient. Once I have this, all I want to do next is maybe not call it next value. There we go, next value, and all I want to do is add this. So I have, let's say, answer. Hey, welcome back. So answer, we're going to start off at 0. And we're just gonna add it in. So actually I'm not even gonna save it. I'm just gonna say answer plus equals this. So let's try this out. Great. Okay. This number, okay, sorry, I forgot that in this I was also using this helper function, which I don't have. I am doing day 9, so I know you were working through it as well, so if you don't want spoilers, you may want to look away. But yeah, we're going through the day 9, and I think we've just solved it. But I think I can also make it better. Anyway, let's try it with the full input, which I haven't even looked at. Oh my, quite long. So let's put it into here. And instead of opening test, we'll open up input. We'll see how quickly this runs, because I think I can make this better. Oh, why is it broken? Oh. How did I break it? List index out of range. How is it working for the previous one? But it's here that it's breaking. Let me just make this bigger for a second. Yeah, I can go through day 5. Let me see. I just want to fix. Yeah, okay. Let's do that. It might be a nice little break. I don't remember what day 5 is anymore. So let me go back to day 5 here. Oh, it was this one. And you were stuck on part 2, wasn't it? Or was it part 1? I remember I was stuck on part 1, I think, at the end of the stream. Or did I do day 5 on stream? I can't remember now. Was it day 3 I got stuck on for a little while? Part 1, okay, that's fine. So God, it feels like ages ago when I did this, even though it was probably like 2 days ago, maybe. Okay, so let me look at my code, because I actually don't remember. But okay, so what we were doing was we needed to start with 79, figure out that 79 is in this range, 50 plus 48, and then convert that to the new range, which is 52 plus 48. And then we go through and do that kind of for all of them. Okay, so let's see how I did that, because I've frankly forgotten. So now I have a very confusing looking convert values function, but I think all that's doing is it's figuring out if it fits into any of the ranges. Yeah, so all this function's doing, so this convert values function. I'm not sure what you mean by brute force. I mean, I just went through and yeah, I might post it a lot on GitHub maybe. Yeah, I'll maybe do that later. I hadn't thought of that actually, but yeah, I might put it all up on GitHub, even though I'm not particularly proud of it, but sure, why not? So all this code is doing is it's just figuring out, given a number and given a list of these mappings, it's just figuring out if the number fits into any of these ranges. So if it'd look at the first range here and go, okay, well, 79 isn't in between 98 and 99, so it doesn't work. But it is in between 50 and 97. So since it is in between 50 and 97, then we know that it's this mapping that applies to it, and then we figure it out. We do the maths to kind of convert it to it. Yeah, exactly. So that's what I did. So I looked through 79. I find out that it's meant to be what is it? It becomes 81, and then down here it becomes something else, and then down here it becomes something else. So I'm going through each level and doing that. So I think most of the function really is or most of the code is kind of just this function here, because this is the one that figures out, okay, is there a mapping that applies? And if there is a mapping that applies, then convert it to that. And also, if there isn't a mapping that applies, the actual number goes through straight, wasn't it? So if for example, 13 or 14 they don't apply here, so they just get added straight as 13 and 14, so they don't get mapped to anything. And so then all we're doing is we're going through all the lines. And then, yeah, just converting them as we go. I can run this just to kind of show you. Well, maybe I'll run it with a test one. But yeah, that runs fine. It's running in 127 milliseconds. You can make it, well, will you be able to see that if I make it bigger? Yeah, there you go. That's running in reasonable time. Quite good time, actually. So that's with the test data there. So you can see it starts off as 79, 14, 55, 13. Becomes 79, becomes 81. I don't keep them in order. I suppose that's something maybe worth noting, is I don't care about the order of them. So I just go through, if I find one that has a mapping that applies, I save it onto a new list, and then at the end, if there's any leftovers, I add them as they are. So 79 and 55 get converted to 81 and 57. And then 14 and 13 didn't get converted, so they just get added at the end. Then I run these numbers through the next series of mappings. And that's it. And in the end I got 35, which is the, well, so then I have my final mapping. I need to find the minimum value in that, which is the min function. So yeah, it's just this function. I'm not sure. 5B, I definitely had to do something to make it more efficient, because I was having some issues with that, I think. Actually, maybe not. Maybe not. But the maths got more complicated. Yeah, exactly. So I just update the seed list as we go. Yeah. Let's get back to why this isn't working, though. Because it's interesting that, once again, it seems like every time you're here, when I try it with my test data, it works, but when I put in the actual input... yeah, if you want to just mention me in the stream, or I don't mind, that'd be very nice, yeah. I don't mind, don't really care too much about how the credit is done, but yeah. A shout out will do, that's all I need. Yeah, we're once again stuck in this case where the test data works and the input data doesn't. And we're getting an index out of range exception, which is just really weird. Because I suppose I'll just print out its and next its. But they should never be empty. Okay, well actually, hang on. Before we do that, I think I can improve this code slightly. Because, so let's go back to the test data here. Yeah, that'll be nice. Thank you very much. No worries. I hope that helps a little bit. Yeah, I think I will go through, maybe later I'll post all of my solutions so far onto GitHub. Do you know what? I could do it... Yeah, no, I'll do it later. But I'll add in everything. Yeah, no worries. Go on. Enjoy. Enjoy your adventing. Okay, so I think we can improve this slightly, because we're actually returning a list in every single case, and I'm not sure we actually need to return a list. Or do we? Because we only actually need the last one in each one, no? Once we've figured out the differences, I look back at my test data here. So, well, let's print out this here. Because so what I'm thinking of is I don't need to return a list, I think is what I'm trying to say. is that in my recursive function, I don't need to be passing in yeah, I do need to pass in a list. That's quite clear to me. But I think I can return a number. Would that work? So we figure out the differences. So next, diff. And then divs.append, like so. Does this still work? No. Sorry, next diff. Okay. This now needs to, oh, sorry. This just needs to be the number 0, I think. Divs.append -1 plus next diff. Okay, and I don't, sorry, and then I don't want to return divs. I think I only want to return my last element. Well, which is actually, well, I don't need to, well, I just want to return this. Yeah, okay. And so finally, there we go. This still works. So that's much better because I'm not actually, I'm not keeping traffic, I'm not returning lists. It's just a little bit more space optimal, I think. Because I'm not, yeah, it's just more memory efficient. I'm not passing in and, or I'm not returning lists. So when I jump up, I don't have a whole long list to keep track of. So this still works. I think 114 was the correct answer for the example, wasn't it? If I go back to day 9, sorry. I think this worked. 114, yeah, that's correct. So, will this have magically fixed anything? No, I still get an issue. Okay, so why would diffs ever still be empty? Ah, so what happens if I have a single element? I think that's what we're maybe asking ourselves. So if I get to a point, let's print out the sequence. Because what I think we'll see is that when we get here, yeah. So I'd like to also print out maybe just like a separator here, just so that I know when one line starts and the other one ends. Okay. Oh, I did not mean to do that. Sorry, just messing with my OBS and let me just move some stuff around that I didn't mean to move around. Okay, so this is the one where it's failing. So, yeah, I think something's going wrong here. So 7, 1, 5, 28, 99. So 7 to 1. That's -6. 1 to 5 is 4. 5 to 28, 23. So that seems to be fine. From -6 to 4, yeah, we have to add 10. That's fine. So where is it going wrong? So this here looks suspicious to me. The fact that we have zeros appearing out of nowhere is suspicious. Because generally I'd expect them all to be okay, anyway, we'll keep looking. So, but yeah, but that is sus to me, let's just say. And it's the second one that it's breaking with, which is interesting, right? Yeah. So it's working for this. Because it's finding 12 to 12 to 12, and then it's going back and it's adding on Maybe let's print out. So I still want to just for debugging purposes. Next value is going to be equal to this. And my answer is going to be value, and I just want to print out my next value before move on. So we should see. Okay. Anyway. Yeah, what is happening here? This just doesn't look right, does it? I feel like it shouldn't look like this. This just seems wrong. The fact that it's going like so. But I suppose you know, I don't think we could be wrong in the maths unless there's something weird about the subtraction going on. But yeah, I don't think there's anything wrong there. So okay, well let's say this is right. Let's just pretend this is right. It looks strange to me, but let's pretend that it's right. So we're going down 0, 0, 0, zeros. Let's see. So we now have 510 minus 74, 5 and 0, minus 584. Yeah, see, I don't think if we only have one difference. What does it mean if you only have one difference? Well, I suppose that means that has to be it, right? So let's say we have... Let's say this was our sequence that we were trying to figure out. I think we just have to assume if we have only a single element, then maybe we just need to return that element. Is that maybe what we need to do? So if the length of my sequence is 1, well then let's just return that single element. I think potentially that's what we need to do. Obviously we don't need this else. Separate them out maybe. Okay. Well, that gave us an answer. Is it the right one? We're about to find out. But yeah, I think that was the trick. That's not the right answer. My answer is too low. Okay. I love that I'm only getting the wrong answers on stream. I promise you, when I was doing these on my own, without streaming, I never got the wrong answer at any point. So I don't know if I'm just coincidentally just doing the hardest ones on stream, or maybe the fact that I'm streaming is kind of distracting me and I'm making mistakes. I'm not sure. So then this mustn't have been right then. Let's print out every time this happens. Only one element. And let's maybe... yeah, I don't know. I suppose I do want to keep that there. But I suppose, yeah, see it happens here. Yeah. I do feel like something's gone wrong here. I suppose I want to find the shortest one where that happens, just to kind of debug it manually. This one seems annoying. Yeah, and this one seems annoying. I ideally want to join... Okay, actually, can I copy the entire output? Yes, I can. And let's look for this. It happens 42 times. So this is the first one. Let's see if there's an easier one that I can kind of look through. See, this one quite instantly went wrong, didn't it? Because again, this looks wrong to me. Like, I feel like we shouldn't so quickly find a case where the differences are all the same except for the start. This seems to be happening a lot. See, this just doesn't look right. But I'd rather get the feeling that something's going wrong, but I don't really see how. But anyway, this one clearly happened quite early on. We already have stuff like that there. So to get from 10 to 9, we did -1. From 9 to 2, we did -7. From 2 to 15, we did 13. From 15 to 46, we do +31. That's correct. Let's see if this is wrong. From -1 to -7, we do -6. Yeah. -7 to 13, we add 20. 13 to 31, we add 18. 31 to 49. 31 to 49, we add 18. From 49 to 71, we add 22. 26. Again, this looks correct. But this is where it appears to go wrong. Because from -6 to 20, it's 26. From 20 to 18, it's -2. And then we have a 0, which is already sus. And then we get 18 to 22 is 4. 22 to 26 is 4, and so on and so forth. So my next question is, are we reading the numbers right? Is that where the issue is? Maybe? Are the numbers being read wrong? 7, 1, -5, 0, 28, 99. Oh, we are reading the numbers wrong, aren't we? Yes. Oh, okay. Oh, okay. My algorithm is correct. I'm just reading the numbers wrong. Because I didn't... Okay, this is why I don't just copy-paste functions from previous solutions. It's this read numbers line, which is breaking because it isn't taking into account negative numbers. So it isn't 7, 1, 5. It's 7, 1, -5. And that's what there's a big difference between those two. Oh, okay. So, what do I want to do? If I see a minus, how do I want to handle that? Can I make... I see a minus. I know there's almost definitely, because in Java you can do like the scanner class and you can just say read number. So Python, oops, read number. Read next number. I have a feeling this will be yeah, I suppose. Yeah, this works, doesn't it? So, what's the reason that I used up? Why did I use read numbers here? It's because of the extra spaces. That's why I used that. But this person is right here in saying that I don't need this. I don't need this, any of this actually, because I can just split. If I go back to my input here, I can just split with the space, and I'll just want to make sure to get rid of the new line at the end. So let's go back. This is going to be line dot split dot replace new line with nothing. Right, sorry, other way around. Whoops. Okay, what did I not like now? Okay, this is true, yes. I actually want them to be ints, rather than, what's W and H here? Well, I know that in one of my previous ones, I don't think it was 8. I think it was, it could have been 7. Maybe it was 6. Where there was somewhere I was using a lambda function potentially. To convert them to it's probably in the B's, wasn't it? To convert it to ints. Somewhere in one of these, I'm pretty sure we're doing some interesting code to go through and make it all. Maybe not. Okay, fine. Let's do this ourselves then. Okay, I'm still going to define a read numbers, read numbers function here, and it's going to get a line. And what we're going to do is we're going to look through, and every time we find a space, we're just going to do substrings and convert those to numbers is what we're going to do. So space, it's going to be line.find space, and so then I'm gonna we need a list, nums, empty list, and then for while length of line greater than 0, what we're going to do is we're going to find the space, and n is going to be line substring from the start to the space, and nums dot append convert to int n. And finally, line is going to be line from space onwards. And it's actually space plus 1 onwards. Like so. I think, and finally we return nums at the end. I think this makes sense, right? So we're finding a space. Yeah, I think this should work. So sequence is now going to be read numbers of line. Okay, local variable space reference before assignment. Where? Oh, sorry. That is very stupid. Okay, something's gone wrong here, because it shouldn't be taking this long at all. Can I just print my sequence here? Feeling something's gone wrong here. Yeah, not even finished. Okay. So something tells me it's not getting to the end. Why? What happens? So once we consume... Once we're here, what does it do? Print space, so I think... Okay, it does do -1. Sorry, break. Okay. If, Hey, Steve. Okay, thanks for letting me know. I'll turn it down. I always feel like the music is too quiet and no one can hear it, but I'd rather you guys hear me, so thank you for letting me know. Cool. Let me know if that's too quiet. I can turn it back up as well. I don't really like having the music too loud anyway. Okay, so now if space is -1, we just break. There we go. . I actually think we no longer need this now. Yeah, there we go. That's much better. Okay, so I think that's worked. Let's see if this is the answer then. I think this is more promising. That's not the answer. Okay, it did say your answer was too low earlier. So I was wondering, okay, what have I gone wrong now? Oh, okay, fine. Let's see at least if we're reading the numbers correctly now. 7, 1, minus 5, 0. Is it reading the last number? I think it's possibly not reading the last number. I think that's what's happening. Sorry. This is day 9, part 1. That is indeed the case. We're not reading the last line, are we? So, 96, blah, 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 blah. Yeah, there we go. I don't want to break. I actually want to, well, if we do -1... Okay, anyway, it doesn't matter. If we'll just add in... If there is no space, then that's it. Nums.append int n. There we go. Nums.append int 9. And then we break. Now that is a bigger number. That looks way more promising. Well, let's just see if the last one is right. So the last one should end in 159, blah, 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 blah. Input 159, blah, 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 blah. Okay, that's correct. Great. I think this is our final answer. I think this is correct. Do we need to wait another minute to submit? My answer's too high. Oh dear, we've gone too far now. Oh dear. Can I just test that this is working with my test data? 114, yeah. It's still working with my test data, so I haven't changed it significantly enough to cause any issues. So where am I going wrong then? Let's go back to our input. Um, 18, the first one? Yeah, okay. 15, 38, 67, 109, 184, 5, and so on. 96, 7, 9, 3. Oh. Oh no, sorry, this is the wrong one. Sorry. Sorry. Let's try this again. I'm just trying to compare. 9, 6, 7, 9, 3, 6. That's the last one. And then it doesn't seem to be struggling with the these. Okay, let's see if this is working then. So let's just run through this manually, I suppose. So we've figured out obviously that the difference is 12. So 207. I'm going to need a calculator here, so I'm just going to open one up. So obviously, okay. So 207 plus 12 is 219. I know I could do that in my head, but I just want to make sure. So now I want to do this plus 219. That's 2107. 2107. Now this plus 2107 is 14,215. Now 61,281. 61,281 plus 14,215 is 75,496. Then 260,567 plus 75,496 is 336,063. And finally, 96,000, or actually 967,936 plus 336,063 is 1,303,999. So that's correct. So I still think it has something to do with negative numbers. I really do have a feeling that this is where the problem lies, is somewhere with the negative numbers it's getting confused. So I wonder if maybe this is the one we should look at next, or potentially. So -7 to 8, -4. Well, I'm not anymore, no, but I did have a problem. Well, I don't think I am anymore, no. But I did have a problem a minute ago where the way I was reading in my numbers, I was actually completely ignoring negative numbers, and so the answer I was getting errors that I shouldn't have been. I wasn't even getting an answer. I was just getting errors because it couldn't find a difference. It couldn't find a point where it reached 0 because the numbers were all incorrect, so there was no actual pattern. So I fixed that, so it actually does read the numbers properly this time. But I'm still not getting the right answer, unless I just submitted it to the wrong one. No, I didn't. Okay, that's fine. Just want to make sure. So I'm still thinking this is where the problem is, because anyway, we've run through this here, and the answer it gave me is correct. It's 1 million and so on. So I'm starting to think that it might still have something to do with negative numbers. But I don't see anything obvious here that looks wrong. There was something obviously wrong earlier, where there was rows that just looked like they weren't possible, and it turned out that was true. They weren't possible. But I don't see anything like that now. All of these look... Oh. Well, this one's interesting. Why did it... This one doesn't look right. Why did it just stop? Oh. That's genius. Okay, I figured it out. Okay, so 13 to 17, we've added 4. I think, yeah. 17 to 20, we've added 3. 20 to 22, it's 2. 22 to 23 is 1. 23 to 23 is 0. 23 to 22 is -1. And, well, it goes -2, -3. I don't even need to do. This is the difference for this one. The way that I am checking if we've gotten to a row of all zeros is totally wrong. I thought I could do something very smart where I'd just go, oh, well, add them all up together. If they're all 0, then the sum of all of them will be 0. But of course, that's not true only for a list of only zeros. Here's an example. If we add all of these up together, we get 0. They all cancel out. So we get 0. So it thinks it's done, but it isn't. It needs to keep going. So there's our problem. This is not true. So that was a very kind of naive way for me to say, oh yeah, that's fine. Yeah, I was thinking, Steve, there probably is a smart way of figuring out is there a list of all zeros. Other than going through every single item and checking if it's a 0, I suspect you might have a much smarter solution that you'd maybe like to share. Multiplying them all together, maybe? Well, that seems like more work than adding them. Yeah, oh, I suppose you're right that is better. Yeah, okay, that's fine. Okay, that's what I was gonna do anyway. I was maybe thinking there was some very, very smart kind of trick to figure it out. But yeah, okay, that's what I was gonna do. And yeah, that's true. That is better than adding them up all up together, because on average it'll be less. It'll break earlier. Okay. I suppose I can just do it here, but so Okay, so let's get rid of that. Because I'm going through the list anyway here, so we might as well do it there rather than twice. So... all zeros. Let's say, let's create something here called all zeros. It's going to be equal to true. And then all I want to do is if any of these isn't 0, if what am I doing? So if sequence I is not equal to 0, well then all zeros is false. All zeros is false. And so then what we do then is if all zeros is true, then we return 0. Otherwise we do that. Ah, shit, I hadn't tried that, Phil. You're right. Is that not the same answer I just did a minute ago? 472. Ah, no, that is bigger. Is it bigger? It looks smaller. It is ever so slightly bigger, and it's the right answer. There we go. That was, yeah, there we go. That was harder than I thought it would be. Okay, yeah, let's get rid of all these annoying print statements. All of these files we no longer need. But that was nice. Ah, no, I didn't need to do. I didn't even know you could do that. Oh, that's cool. Okay. There we go. So, where am I still printing things? Ah, there. There you go. Yeah, it's a very nice problem. I liked this. I think this is the first one where I've done any sort of recursion. Oh dear, I have some messages on my phone that require my immediate attention, so give me a second. Okay, guys, I'm unfortunately going to have to jump out. I should be back in about maybe 20 minutes. So I'll probably leave the stream on. I'll put in an intermission screen here. But I'm going to have to go for a little while. But we finished 9A anyway. When we come back, we'll do 9B, which I haven't had a look at yet. But yeah, that was a nice puzzle. I'll be back in a little while, and we'll move on to part 2 of day 9. Okay, well, it turns out, well, I don't know why there's people still watching. It's just music playing on an intermission screen. But it turns out I'll need to be gone a little bit longer than 20 minutes or so. So I think what I'll do is I'll stop the stream and maybe I'll host someone. I don't know how that works. I've never done that on Twitch. I need to find a streamer that I want to host. Is that how it works? But
Hey, hello, how are you feeling?
oh dear, no. But yeah, I'm gonna have to be gone for a little bit longer than 20 minutes or so. So I'll just come back. When I come back, I'll start streaming again. But for now, we'll do that. So okay, how does one do this then? So how do I host or raid or whatever? You know. I am live on Twitch right now, haven't I? I haven't actually checked. Yes, I am live. Anyone with experience in the industry know how to host someone else, or is that something maybe I can't do? Okay, time to Google it. Okay, there we go. I figured out how to do it. Apparently it's not hosting anymore, it's called raiding. So we're going to be raiding Trucker Dylan. It's a channel I found a while ago. For those of you that like Euro Truck Simulator or American Truck Simulator, this guy does it IRL. That's about it. He's a trucker, and he has some cool camera angles on his truck, and he drives around Europe. I think he's from the Netherlands, so he drives around the Netherlands a lot. But he's streaming right now, so we'll raid him. So anyway, yes, I still need to go. I will come back in maybe 40 minutes or so, and I will we will resume our Advent of Code with part 2 of day 9. So thanks for joining, the people that did for this first part, and I'll see you soon, hopefully.